Okay, I'm starting on page 498. That's where the section starts for dilations 10.6. Okay, it's another type of our transformations, except this is not a rigid transformation. Rigid transformations maintain the same size as the original pre-image. Dilations are enlargements or reductions, so it doesn't have the same size as the original. So it's not a rigid transformation. That's why we do them separate. Our reflection, our translation, and rotation were all rigid transformations. You get the same size that you started with. Dilation is an enlargement or a reduction. Okay, if you've gone to the eye doctor, you've had your pupils dilated so they can like see in your eye better, and then you have to wear those weird little glasses, whatever, until your pupils go back to normal, so it doesn't let too much light in your eyes. Okay, I hate when they do that, but anyway, so if the K is the scale factor, that's the ratio that they're using to either do the enlargement or do the reduction. If the scale factor is bigger than 1, so that means if it's 2, if it's 5, if it's 3, if it's bigger than 1, it means that it's an enlargement. They made the image is an enlargement of the pre-image, the original. If the scale factor is between 0 and 1, that means it's going to be a fraction, like a third, a half, 2/3. Then it's going to be a reduction. It's going to be smaller than the original pre-image. Now remember, in the book, when we are doing all these transformations in this chapter, the black drawings are your original pre-images, the original figure, and then the red is the transformed image. So if you look down at the bottom, page 498, you have an example of this. You have this little black triangle ABC here, and then you have a bigger one. So since it was bigger, it was an enlargement. That is an example of a dilation. Now you'll see that they always talk about a center of dilation, which they usually use in this book, point P, as the center of dilation. So that's kind of like your focal point, where you can see they drew the lines connecting the vertices, lining them up to show how it just got bigger from that or smaller from that. Okay, so the original is the black, the red is your pre-image, your new image. So like on this one, you have the original black figure, and then inside you have the smaller red one. So this one was a reduction because it went smaller down on the inside. So most of what we're going to be doing on these today is just stating whether or not it would be a reduction or an enlargement. And then we'll talk about the scale factor some as well. Now, on our other transformations, remember they had like 6 characteristics that they kept preserved. Those were listed in section 10.4 that we talked about at the beginning of class yesterday. For the dilations, we only have 4 characteristics that are preserved, and they're on page 500. Collinearity of points, so if points were on the same line to start with, they're on the same line in the new image. Then you have betweenness of points, angle measure, and parallelism. All of those stay the same, okay? Now, our work that we're going to be doing is on page 502, okay? So on page 502, and we're not following exactly what the directions say in the book, but we're doing most of what it says, okay? But our key things that we're looking at is first figuring out whether it's an enlargement or a reduction, and then if it asks about scale factor, we'll talk about the scale factor too. Okay? So is everybody getting their book out on page 502? Okay. Everybody should be getting their book up to page 502. So we're ready to do these. Okay. So on page 502, The directions in here tell you to copy each black figure in its red image and locate the center of dilation P, then state whether it was an enlargement or a reduction, and whether that means K was greater than 1 or K was between 0 and 1, okay? I'm not gonna make you try to copy these figures and draw them on your paper. There's no need for that, okay? We can look at them and we can tell whether it was an enlargement or a reduction. And based on that, we know either K was greater than 1 if it's an enlargement, or K was between 0 and 1 if it was a reduction. Okay, so that's the main thing I'm worried about. I'm not worried about you being able to trace these figures out of your book. So looking on here for number 1, remember which one is your pre-image and which one is the new image. Okay, so remember what I said about which one's pre-image and which one's the new image. On here, Michael, is it an enlargement or a reduction?
Number 1.
Number 1.
Reduction.
It's a reduction because the new little red triangle is smaller than the original. So all you have to put is reduction. And since it's a reduction, that means that K was between 0 and 1. So that's all you have to do on here. We're not worried about having to draw them. We're just figuring out whether it's reduction or enlargement and what that means the K would be. Okay. Kaya, what about number 2? Reduction or enlargement?
Enlargement.
Enlargement, because remember your red image is your new image. So it's bigger than the original because it's outside of it. So that means K was greater than 1. Okay. Number 3, Javier.
Reduction.
Reduction, because the red one, the new red one is inside of the original. So if it's a reduction, that means K is between the 0 and 1. Okay. Number 4, Mia.
Enlargement.
Enlargement, because that red line's a lot longer than the black original one. So enlargement, which meant K was greater than 1. Okay. So pretty easy. Okay. Now, for the next 4 problems, they're a little bit different. Now, it tells us to determine whether the red figure is a dilation of the black figure centered at P. If so, find the value of K. If not, explain why the transformation is not a dilation. Okay, so what we're doing first is looking at it to see, yes, it looks like an enlargement. No, it doesn't. Okay, I mean a dilation. No, it doesn't. So on number 5, you have your original longer black line, and then you have the shorter red one. So is that a dilation, first of all? Does it look like they line up with point P at the top, that it's a dilation? We're on page 502, Pedro. Okay. All right. So does it look like these endpoints of the 2 lines would be in a line with point P? Yes or no?
Yes.
Yes. So that means yes, it's going to be a dilation, and it's what type of dilation?
Reduction.
Reduction. Okay. So that's what I'm worried about. I'm not worried about you all actually figuring out K on this one. Okay. Because if you were going to try to figure out K on this one, then you actually have to like measure the sides and stuff. And I'm sure if I asked you to like try to find rulers and stuff, that would not happen. So we ain't worried about that. We're just worried about whether you know it's a dilation or not. Okay. Pedro, did you find 502? You with us? All right. Number 6. Look at it. Look at point P. Does it look like you could draw a line from point P to the vertices of the triangles that it would be connecting them. So it would be a dilation, yes or no, Karnaya?
Yeah. No.
Oh, thank you. He answered for you, Karnaya. What'd he say?
Yes.
He said yes. Is it going to be a reduction or an enlargement?
Enlargement.
Enlargement, because the red triangle is way bigger than the original image, the original pre-image. Okay. Number 7, look closely at number 7. Point P is actually the vertex of both of those things down at the bottom. Okay. But if you look at them, could you draw a line that would go through the vertex, the vertices of each one? Would they match up with a straight line?
No.
No.
They're not even. Looks like.
Not even, right? Now, if you look, they're not even the exact same shape, are they?
Mm-mm.
No. So they're different shapes. Okay. It's not going to be a dilation because they're not even exactly the same shape. With the dilation, they're the same shape. It's just one smaller or larger than the other. Okay. All right. Number 8. Number 8 on that one. Look at where the point P is. Can I draw a line from point P to connect to the vertices of both of them at the same time? Yes, thank you for muting him. Okay, so is it going to be that? Okay, look back at the example I looked at on page 5. Which page was it? Page 5, 499. When you had point P down here, you'll notice both the red new image and the original pre-image both met at that point. That was your center point. Now, when you look at this one, is P the center point? Is that where the red triangle comes from? Yes or no? Does the red triangle come from down here to you? Is it even at that vertex?
No.
It's not there. So P is not the center of that dilation. So no. And you can put P isn't center. Okay. So that's 1 through 8. Everybody got those down?
Yes.
All right. Now, we did 1 through 8. Now, the next ones that I had that we were going to do are on 28 through 31. So you need to look at the next page for these. Okay, they're here, kind of in the middle of the page, right above whatever that picture is, a little airplane or drone or something. Okay, so we're doing these right here. It's kind of in the middle of the page there. Okay, 28 through 31 is where we're at now on page 503. On these, for these directions, it says, find the scale factor for each dilation centered at point P and state whether the dilation is an enlargement, reduction, or identity. Now, to be an identity dilation, that would mean K was equal to 1. Okay? If K is greater than 1, it's an enlargement. If K is between 0 and 1, it's a reduction. If K equals 1, it's an identity. Okay? If K equals 1, it's an identity. Okay, so those are our 3 main ones, but you don't have this one very often, just like you don't have an identity transformation very often. We had 1 or 2 of those, I think, in yesterday's stuff, but you don't see it very often. Okay, so on number 28, the way we're going to do this is you're going to have to do just a little math. Okay, it says PL is equal to 10 units. And PL prime, that means your new L point, so that would be in your new image, is equal to 30 units. Now, when you are trying to find the K, the new image length goes over the pre-image length. Okay? K is equal to the image over the pre-image. Okay, so remember on these, our new image is the red one. The pre-image is the original, it's the black one. If it's got the picture. If it's got the points, like we have on 28 through 31, the one with the little prime mark, the little accent mark after the letter, is your new image, and the one without it is your pre-image. So I'm going to have to write a fraction. Which number is going to go on top? The 10 or the 30?
10?
Is that the new image or the original?
The original
That's the original. Where's the original go?
in the bottom.
On the bottom. So I'm going to have 30 over 10, which reduces to 3. So 3 is definitely bigger than 1, so that means it's an
Enlargement.
enlargement. Okay? Now, like I said, those others that they wanted us to find the scale factor on, you actually would have had to measure. And I know most of you, I wasn't going to try to get you all to have something to measure with. So that's why we didn't do that. But on these, it's given us the measurements so we can find the K, the scale factor. Okay? Number 29. It says PN is 20 units. PN prime is 5 units. Which one goes on top?
The prime.
Okay, so that was what number?
Oh, 20. Oh, 5, I mean.
5 goes on top. So I have 5 over 20. I can reduce that. So I get a fraction. A fraction is between 0 and 1. So that picture is a reduction. Okay? Number 30. Number 30. It says M prime N prime equals 8 units and MN equals 8 units. So the prime one, remember, is your new image. So it goes on top. But what do you notice about these? They're the same number, right? They're the same number. So 8 over 8 is just 1. So it's an identity dilation. Okay. And then 31 says M prime N prime is 14 units and MN is equal to 7 units. So which number is going to go on the top? Pedro.
What happened, miss? I came back.
Yeah, you shouldn't have been gone to begin with.
All right, miss. I was doing something.
Yeah, this is my time. All right.
Mil disculpa, miss.
Mm-hmm. On number 31, which number goes on top to find my scale factor?
Seven.
7, because that's your original, because it does not have the little prime markings on it. So I have 7 over 14. 7 over 14 reduces to a half. So when I get a half, okay, when I get a half, that's between 0 and 1. So that means it was a reduction. Okay. So we've talked about our dilations. We did number 1 through 8. We did 28 through 31. Now you'll notice the last problem that I had on here was number 33. So I need everybody to look at number 33 on there. If you notice, it's a big table that is reviewing all of our rules that we've talked about so far with our different transformations, okay? These things are things that you should have. Javier, would you stop? That's so distracting. All right, these things are things that you have in your notes if you wrote your notes that I gave you on the board. Okay, remember there were certain rules that I told you for each thing, our reflections, our translations, our rotations. So that's what this is. It's those things from the notes. You just got to be able to find them and put them in there. Some of you, I don't think you had actually written them down because these are the things you were supposed to use for that quiz the other day, and some of the numbers that you were coming up with looked nowhere like what these rules are. Okay? Like, on none of them did you put 90 in the ordered pair. Just because it's like a rotation of 90 degrees doesn't mean 90 is one of your coordinates in your parentheses. Okay? Some of you were like, it said to subtract 3 and you multiplied by 3. I don't know what you were doing. Okay? If it's a -3, that means you subtract 3 from it. So we're going to go through these again. We're going to talk about that so some of you can fix or even send your quiz in for the first time. You know, because a lot of you haven't done that. It was only 5 problems, people. All right, so let's look at 33. Now, the first one says reflection in the y-axis. Okay, so if I'm doing a reflection in the y-axis, I'm abbreviating up here, your original points are your xy. Your new points, when you reflect over the y-axis, you got to think about your coordinate plane. Your coordinate plane, here's the x-axis, here's the y-axis. So if I'm reflecting over the y-axis and I'm up here, it goes over on this side. So it's just going from the right to the left. So if I'm going from the right to the left, I am changing my x value. The y value is going to stay the same. I'm not moving up or down. I'm changing from right and left. So for that, it's going to be the x becomes a negative, the opposite, and the y stays the same. Now, if you are doing these on a problem and x was already negative, that means it started off on the left and then you were moving it to the right, so the opposite of the negative, it would become positive. Okay? But you just do the opposite of whatever x is and y stays the same. Now part B. Part B says reflection in the x-axis. Okay, so reflection in x-axis. All of these were on notes that I gave you the other day, plus we reviewed them the other day before you took your quiz and did several of them together. Okay, so if I'm reflecting over the x-axis, my original coordinates are my x and y. And then my new coordinates, reflecting over x, here's my x-axis. So that means if it's in the top, it's going to go down to the bottom. If it's in the bottom, it's going to move it to the top. So when you're reflecting over the x-axis, you're changing the up and down, which is your y coordinate. So the x coordinate is going to stay the same. The y coordinate is what you're going to change the sign on. So we're completing our rules in that table on number 33. Now part C switches gears, and it's talking about a translation. Okay. Translation with vector AB. Okay, remember the little V is your vector. Okay, AB. So that means it's telling you the first number tells you what you are adding or subtracting to the x. The second number tells you what you are adding or subtracting to the y. If it's a positive, you are adding. If it's a negative, you're subtracting. So this was like number 1 on your quiz. It was like a translation vector of -3 and 1. So it would mean you subtract 3 from every x coordinate and you would add 1 to every y coordinate. Okay? So on here, my original xy, when I go to do this, I'm going to have x plus a is my new x coordinate, and y plus b is my new y coordinate. Okay, the a and b here is just positive, so I put plus for both of them. But again, if it said minus, then if it was a negative, you would subtract it. Because that would tell you you're going to the right and up with this. If they were negatives, you would be going to the left and down. The next one was a rotation of 90 degrees. Now, if it's a positive value for your rotation, it's a positive number for your rotation, then that means it's going counterclockwise, because that's the way we count on our coordinate plane. Quadrant 1, everything is positive. Quadrant 2, negative and positive. Quadrant 3, everything negative. Here, positive and negative. But we start at the top one and go counterclockwise. So if we got a positive number, we're going counterclockwise 90 degrees. You had these rules on your notes as well for your rotations. And this was like number 5, I think it was on the quiz, was a rotation of 90 degrees. Okay, if you were rotating 90 degrees counterclockwise, which like I said was like number 5 on the quiz that you had the other day, for your X's and Y's, that means you're going from this, for example, this quadrant to this one. Well, here, everything's positive. Your X is positive, your Y is positive. Everything's positive. Here, the first thing is negative because it went to the left, but then it's still positive. So that's kind of what you do for this, but you switch the order, and then you change the sign of what's going to be in the front. So it's going to be negative y and then x. You switch the order of your two coordinates when you're rotating because it's turning it, and then you change the sign of the one on the front. So if it was already negative, it would make it a positive. If it's positive, it makes it negative. Part E was a rotation of 180 degrees. I don't remember if you had one of those on the quiz or not. I know we did one as the example the other day. Remember, 180 degrees is going the exact opposite, okay? So I'm going the exact opposite. So if I'm going this way where everything's negative, and then I'm going back this way where everything's positive, okay, I do the exact opposite. So what we're going to have on here is you're going to have X and Y, and then it just changes the sign because it's turning it exactly the opposite direction. So you're going to have negative X and negative Y. Okay? So for rotation 180 degrees, because you're going from here all the way down to here. Everything was positive up here, everything's negative down there. Okay? Then the next one I had in our table was a rotation of negative 90 degrees. Now remember, when we're talking about a negative 90 rotation, you're going the exact opposite way. So we're going clockwise, the correct way going this way. Okay, we're going clockwise. So when you are doing that, going 90 degrees this way is the same as going 270 degrees the other way. Okay, and I told you that when we went over this. I had it written on your notes. Like we had our original 90, 180, 270, and then out to the side I put the negative ones that went with it. So this has the same rule as 270 degrees positive rotation. So that means I'm going like 3 quadrants this way, or I'm going just 1 this way. Okay, negative 90 is going 1 this way, or that's the same as 270 going 3 this way. Okay, well down here, you have a positive and then a negative. Okay, so that's what we're gonna have. You're gonna have your original points, and then we switch the order like we did on the 90 degree. Okay, you switch the order like you did on the 90 degree. Y goes in the front, X goes in the back, but then you change the sign on the one in the back because the first one's the positive, the second one's the negative when you go there. Okay. And then for the last one, for G, it's a dilation. With K as its scale factor, okay? So basically what you do on a dilation is multiply by the scale factor. So my original point is X and Y. So my new point would be K times X, K times Y. So if I was doing an enlargement and it had a scale factor of 2, that means it's twice as big, right? So I take 2 times my X value, 2 times my Y value. If I had where it was a reduction of a half, I'd take half of my X value, half of my Y value to find my new coordinates. Okay, so this I was just kind of reviewing to make sure you have that for your rules. You definitely need to make sure you have those rules in your notes for these, okay? Now, some of you still haven't sent me that quiz, so you need to get that to me today. All you have to do is type it in an email because it was like triangle D, E, and F. So the way you would send it to me is you would have like number 1, D prime, E prime, F prime. Number 2, D, whoops, that's a D. D prime, E prime, F prime. Whatever your new coordinates are is all you have to do. Okay, so like, I don't remember what the points were or anything, but like I told you, if it was like I had a translation vector of -3, 1, and I do not think these are the right points from your quiz. I don't remember them. I'm just writing down numbers, so as an example, okay? So let's say number 1, I was doing a translation of -3, 1. And I'm just putting some points on here. Okay, so this says -3 to my X value. So that means that for my X values, I subtract 3. So I would have 1 minus 3, which is -2. And I would have 2 plus 1 because it's positive, which is 3. And then for this one, I would have 3 minus 3, which is 0. And I would have 0 plus 1, which is 1. This is how you find your coordinates. This one, I have -1 minus 3 would be -4. And -2 plus 1 would be -1. So this is how your answers should be looking when you're doing the quiz. Okay, if it's doing the translation vector, if it's negative, you subtract it from your X. If it's positive, you add it. Same thing with the Y. Now, if it's talking about a rotation, okay, let's say we're rotating 90 degrees counterclockwise. Okay, that's what we're doing on this one for number 2. So to do a rotation for 90 degrees, we did that right here. That was this rule. We said we switch the order of the X and Y, and you change the sign on the one that ends up in the front. So for this one, for my example that I'm doing down here, I switch the order of my X and Y. So 2 goes in the front, 1 goes in the back. And then I change the sign on the one in the front, so it would become a -2, 1. On this one, I switch the order, and then I change the sign on the one in the front. But do you put a negative on 0? No, you don't put negative on 0. Okay, so you leave it like that. This one, oh, here's my original. -1, -2. So I switch the order, -2, -1, and then it says I change the sign on the one in the front, so that would make it a +2, -1. Okay, so this is what I was talking about for your quiz, and I've done several examples that day, but most of you, if you missed them, it was like one of the rotations and then your translation vector number 1. So if you haven't done that yet, you need to do it and do it correctly. Or if you had done it and I sent back that you needed to try to fix stuff, okay? But like I said, half of you haven't sent it to me to begin with, so hopefully that helps. Or if you did it, but you know you didn't do it right, redo it, and send it in to me today. Okay, when do I need it? Today.
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 Now, I stayed on the other day and worked more with chapter 9 stuff for quizzes and tests. So y'all need to make sure you've got that stuff caught up and done and sent to me. Okay, tomorrow I will go through and message some of you about trying to stay after a little bit, and we'll work on some of your stuff you still owed from chapter 8. Okay,
Oh,
trying to break it up a little bit so it's not all on one day, because y'all can't handle doing it all in one day. I can't handle doing it all in one day. I've already got enough gray hair from y'all this year. So we're not going to do that. We're going to divide it
I
up.
would think so, man.
We'll work a little bit more on chapter 8 stuff tomorrow. Okay? So does everybody know what they still need to do as far as for the quiz, if you still got to do that or not? Yes or no?
Yes, ma'am.
I have too much work, miss.
Well, if you had done it when it was originally
Sure.
you wouldn't have a whole bunch. But you waited, you keep putting stuff off, that's when it builds up. Okay, so make sure you've got all your answers from today on our dilations. Okay, were dilations pretty easy? Yeah,
Yes, ma'am.
our enlargements and reductions. We have one section left in chapter 10, which is called Tessellations. So I would ask that you read it. It's only 2 pages is short, because you don't have to read the picture part, so you just read the thing. So it's not much at all. Okay, but if you kind of read through here, there's not that much there. And the top right here, see, it's not much at all. If you read through that before we start class tomorrow, it will help, especially because the one thing where we're talking about the numbering system, that kind of confuses people a little bit more. So if you kind of read through it before we get to it, and then when we talk about it tomorrow, hopefully that'll make it a little bit easier to sink in. Okay, but then we'll be done with chapter 10. We're just doing a little bit from chapter 11 and 12, some of the high points, especially because chapter 12 is stuff that normally is kind of more like in like a pre-calculus class. So if we don't cover all that, we're okay. Okay, we're going to hit the main part that I know you definitely need, especially for when you go to take like ACT and stuff, you know, if you're planning on going to college. So we'll hit that part, and then we'll be reviewing for your big exam, which will be 2 weeks from today.
Yay! I can.
Be quiet, Pedro.
All right, so
Quiet, Mike. I'm not talking to you.
oh, all of you be quiet. How's that? So make sure if you haven't sent me your quiz, you send me your quiz. Read section 10.7, and then I'll see you tomorrow at 11 o'clock.
Okay.
Bye. At
All right,
11
man.
o'clock, Pedro. 11 o'clock.
Yes, ma'am. I'm going to try to stay late tomorrow
Okay.
to talk about some of the geometry test stuff and all that.
Uh-huh. That you never bothered to do?
Yeah.
Yeah. Uh-huh. Yeah. All right.
All right.
Bye.
Bye, Miss.